Welcome back again, everybody. Mr. Mitchell here. We're going to be looking at angles today. As we move into our geometry section, we've already talked about points, lines, rays, segments, planes, all of that kind of stuff. And now we're going to look at how we use those things to create other things, such as angles. Now, I'm assuming in elementary school your teachers probably taught you most of what you see on the screen right here. Specifically, though, let's do a quick review. An acute angle is an angle, if we remember, that is less than 90 degrees. So as we look at acute angles, that's how we tell what they are. An obtuse angle is an angle that is greater than 90 degrees. So obtuse angles would be more than 90 degrees if we were measuring from one side to the other. A right angle, hopefully your teachers taught you this as well, a right angle is exactly equal to 90 degrees. So if you look at like a corner on a piece of paper or something like that, that angle right there is 90 degrees, and I'm assuming your teachers probably taught you that as well. Something they may not have taught you is this last figure here, a straight angle. And basically a straight angle is just a line. If we were to measure from one side of the line around this point to the other side of the line, then we would get a measure of 180 degrees as we go from one side to the other. So a straight angle is exactly equal to 180 degrees. What we're going to be looking at, though, is how do we use those different angles to form different relationships with those angles. So for example, if we look at what we have on our screen here, one of the things that we're going to look at first is this right here. If we look at the angle ADB, and we notice, first of all, that it's connected to angle BDC, we call that an adjacent angle. Anytime that you have two separate angles that are sharing one side, okay, our side here is BD, if they are sharing that one side, then it is called an adjacent angle. And we have the same thing in our other figure where we have two separate angles sharing one line. And this time it's this line right through the middle. So the first thing we need to look at, we need to recognize is that these two different lines are adjacent angles. So the definition for an adjacent angle would be two angles sharing the same line. Or same side, rather. The next thing we want to look at with these two angles is, if you notice in our first figure here, if we were to ignore the line segment BD, or that side of those two angles, if we look just at this part of the graph of our figure ADC, hopefully you guys are noticing that this is now a 90-degree angle. And when we have that situation where two angles together form a 90-degree angle, we call that a complementary angle. Okay, so you go ahead and put that into your notes as well, complementary angle. And a complementary angle is two angles who form together 90 degrees. Okay, so complementary angles are two angles that create a 90-degree angle. Off to the right over here, we have another figure, and this time, once again, with our adjacent angles, this time, as you can see, we are forming a perfect straight line. And these are also a special name. This time, these are called supplementary angles. And the definition of a supplementary angle would be two angles that together form a 180-degree angle. So supplementary angles form a line that is exactly 180 degrees. So those are two of our relationships that we need to know. Complementary angles form 90 degrees, and supplementary angles form a line that is 180 degrees, or form an angle that is 180 degrees. Oops. Okay, so let's move on and let's look at a couple other relationships. And here we have our final relationships that we're going to look at. And we're going to look at these two relationships. First, this relationship on the left where we have two lines that intersect each other or that cross each other. And when two lines intersect each other, they form different angles. So I have angle A, B, C, and D. The interesting thing about these is that when we have two lines that intersect, it creates what we call vertical angles. I'm not sure if you guys were taught this before, but basically a vertical angle is if you have two lines that intersect each other, angles that are opposite each other are called vertical angles. So if I'm looking at this graph or this figure here, angle A and angle C are vertical angles. They are directly opposite one another. Also, angle B and D are vertical angles. Again, directly opposite each other. What makes this interesting is that vertical angles have the exact same measurement. So if we're looking at a way to represent this, we would say the measure of angle A, measure of angle A, is equal to the measure of angle C. And the other representation that we can have for this particular graph is the measure of angle B is equal to the measure of angle D. So vertical angles are angles that are formed when two lines intersect and opposite angles are equal to each other. So A is equal to C, B is equal to D. Our second form that we have over here, our second figure, as you can see, we also have vertical angles again, where line T has crossed line L, so we have 4 vertical angles there, and line T has also crossed line M, so we also have 4 vertical angles here. So we have 2 sets of vertical angles. Now, the interesting thing about this particular figure is what we're going to look at is called corresponding angles. And corresponding angles, corresponding angles are angles that are in the same location as other angles. What I mean by that is this. If we look at angle 1 in our first set of numbers here, it's formed by the line T and line L, and it's in the upper left-hand corner. A corresponding angle to angle 1 would be angle 5, where if we look at these 4 vertical angles, again, it's in the upper left corner of those 4 angles. And it's corresponding because they're in the same location. So what I'd like you guys to do is try to figure out what are the other corresponding angles, and you can pause your video and write those down. And then we're going to talk now about a couple of other relationships. Within this, there is also something called alternate interior angles. So let's write that out. Alternate interior angles. Now, if we're talking about interior, if you guys think about the word interior, usually interior means inside. And in this case, that's true. We're talking about the angles that are inside these two lines, line L and line M. So inside line L and line M, we're looking for alternate interior angles. Okay? The way this works is this, and this only works if we have parallel lines. So as we have L and M, those are parallel lines, alternate interior angles are equal to each other. Meaning, interior, we're only going to look at 3, 4, 5, and 6. Alternate meaning opposite each other. So if I'm looking at angle 3, the opposite of angle 3 is angle 6. It's on opposite sides of line T, and it's on opposite lines where angle 3 is on line L and angle 6 is line M. So alternate in every possible way. Angle 3 is equal to angle 6. And we can represent that by saying the measure of angle 3 is equal to the measure of angle 6. And there's another alternate interior angle on there as well. Other than just 3 and 6, there is also, and here's where you get to pause the video and you get to write out the other alternate interior angle. So hopefully you came up with measure of angle 4 is equal to measure of angle 5. So the last part of today's lesson is we are going to look at another figure, and I'm going to give you some information, and I want you to be able to think about all the stuff we talked about and try to figure out the answers to that. So let's go ahead and get that started. So here we have our figure once again with line T intersecting the parallel lines L and M. And what I'm going to do is this. Let's start off by saying that angle 1 is equal to, let's say 110 degrees. Okay? So angle 1 is equal to 110 degrees. What I want you guys to do is I want you to figure out all the measures of all the other angles that we have in this problem. Okay, and what you need to do is you just need to think about all the different relationships that we've discussed so far today. Think about supplementary angles, vertical angles, corresponding angles, alternate interior angles, all of those different things. So I'm going to help you out with the first one just to get you started. And what I want you to look at is if the measure of angle 1 is 110 degrees, what would the measure of angle 2 be? Okay? Think about all the different things that we've talked about. What would the measure of angle 2 be? Go ahead and pause your video if you need to think about it a little bit more. Measure of angle 2 in this case is going to be 70 degrees. And the reason that it's 70 degrees is if we think back to the beginning of the lesson, we learned that a supplementary angle, okay, angle 1 and angle 2 are supplementary, meaning they form a straight line. Those two angles together equal 180 degrees. So if angle 1 is 110 degrees, then angle 2 needs to make up the difference, which means 110 plus 70 would be 180 degrees. And I can continue this train of thought by thinking about if angle 1 is 110, I can jump straight to angle 4. Because they're vertical angles, angle 1 and angle 4, then that means that those two angles are equal to each other. So that means that angle 4 also has to be 110 degrees. And that is all the help I'm going to give you on this one. So I want you guys to go through and figure out the rest of the angles, figure out angle 3, 5, 6, 7, and 8. And I will see you all tomorrow in class.